So you have been a tech consultant and you have been doing a lot of things, including as a startup CTO, right? Now you are writing a book titled Adaptive Systems with Domain-Driven Design, Wordley Mapping, and Team Topologies, Architecture for Flow. So tell us more, how did you come up with this topic? It's like very long and three different techniques all in one. So maybe can you tell us a little bit more story about that?
Yeah, so it started first with domain-driven design in my career. So when I was starting the journey from monoliths to microservices, then domain-driven design came along. It put its focus on partitioning your problem domain into smaller parts and then decomposing your problem domain into modular components, the bounded contexts where related behavior shall sit together and also where bounded contexts reflect good candidates for microservices. So that was the first encounter with domain-driven design back then. The second encounter was when I was listening to Simon Wardley's keynote at Serverless Conference back in 2018 in Hamburg. He talked about what Wardley mapping, about how to create situational awareness and to design and evolve effective business strategies. And I have to admit, at that moment when I listened to his very entertaining keynote, I was really puzzled because it was really interesting. It also sparked my curiosity again. And I was sitting there in the audience and was thinking, oh, yeah, that sounds really interesting, but how can I apply it to my case? How can I apply this to my context? So I was then diving deeper in that because I was sparking some curiosity. And then it came along with that it is very combinable with domain-driven design because Wardley mapping itself is a strategic framework that was invented by Simon Wardley, and it helps to design and evolve effective business strategies that is based on situational awareness and movement following a strategy cycle. The strategy cycle is a representation of change and how we need to react to it. And it also comes with 5 different sections. One of them is the doctrinal principles that you can apply as an industry regardless of your context, and that prepares you to respond to changes, and how the application of doctrinal principles prepares you to create or to respond better to changes. This was also the moment where domain-driven design and Wardley mapping are beautifully working together, because domain-driven design helps with applying these doctrinal principles of Wardley mapping. So one doctrinal principle is, for example, that you should partition your landscape into smaller parts. So for example, where we have domain-driven design, decomposing or partitioning your problem domain into subdomains, or decomposing when you go to the solution space of strategic design, where you decompose your problem domain into the modular components. And also another aspect is also using a common language that, for example, Wardley mapping suggests. That is also one core aspect of domain-driven design, where the collaboration between the domain experts and the development teams is an essential part in order to gain domain knowledge, which is described in terms of the ubiquitous language, the shared language, where we come back then to the common language that is described in the doctrinal principles. There are a lot of more doctrinal principles that domain-driven design is automatically applying, or you apply automatically doctrinal principles while applying domain-driven design. So that's where they are really beautifully working together. And also another aspect is, for example, the landscape. The strategy cycles also have one section that is the landscape, that is the representation of your environment as an organization is operating and competing in. It is visualized with a Wardley map composed of a y-axis and an x-axis. The y-axis is representing the value chain composed of users and user needs and components that fulfill the user needs either directly or indirectly. The user needs, on the other hand, also reflect the problem domain in domain-driven design. And also domain-driven design lets you also discover your core domain that is then providing a competitive advantage. That's whether you should strategically invest in most. So it creates also situational awareness that is also supported by Wardley mapping. So I combined Wardley mapping with domain-driven design first. Later on, Team Topologies came out in 2019. I was like, oh, why didn't I have this book already available when I was starting the monoliths to microservices journey with my teams, with my colleagues at the startup? Because we were not really optimizing for fast flow of change. Everyone was trying to solve the complexities, the infrastructure and operational complexities of microservices that come with it. Instead, we should have the streamlined teams and then later the platform teams, and we mingled everything together. So the team's cognitive load was largely exceeded. So there was the moment like, oh no, gosh, that should have been available when I started the journey. But anyhow, when I read this book, I was also thinking, yeah, It's also applicable in these connecting the dots between these three perspectives, because also the well-defined team types and the well-defined interaction modes of team topologies, promoting organizational effectiveness, and also have the focus on the stream of change, the fast flow of changes. Then by applying them, we also already apply the doctrinal principles of Wardley mapping in terms of like flow optimization, and also think small teams and provide purpose mastering and autonomy. So they are all connected somehow together. I was thinking like we need to consider our system that we build as socio-technical systems when we go into a broader perspective that brings the system thinking perspective, in that a system is more than the sum of its parts. It's a product of their interactions. That's the reason why I like to connect the dots between these three perspectives, because they have more focus on improving the performance of the whole instead of separate parts of the system.
Thanks for sharing all this. For people who are probably trying to scramble, like how does it look like, the interaction? So maybe later on we can put in the show notes. You have a beautiful diagram actually to represent all this. I'll make sure to put in the show notes. But in the first place, all these three techniques in your book you mentioned, they will support you to build a more adaptive system. You also mentioned about fast flow of change, lesser cognitive load, and things like that. How does these three actually helps you to build a more adaptive system? And in the first place, why adaptive system is actually important for us?
So you focus on where the most important changes in your system occur. So to know where your stream of changes occur and to focus on that one in order to improve the fast flow of changes. So that's the first aspect. And then also the other one is to find suitable team boundaries, and also to optimize their team cognitive load and avoiding bottlenecks in terms of also minding the dependencies and the coordination and communication efforts between teams. Having also Conway's law in mind, that the communication structure is reflecting also the resulting or resembling a system design. And also we have to break our monoliths into smaller parts. We have to split our teams into smaller teams. We need to focus on clear team ownership boundaries, and that also brings it all together. So it's like we have to have an organization, or we have to prepare that change itself can flow through our organization without constant reorganization, with constant restructuring. And also that comes to our software design with domain-driven design. So when we have a change and we want to change our system, we need to focus that this change is not affecting the entire system, so that we have to rebuild everything in order to make this change effective. That means that we have to concentrate behavior in specific places, or we have to identify the seams or the bounded context, the boundaries where related behavior sits together, in order when we change that behavior, we only have to change it at one place. So in order to prepare for adapting fast flow is to mind the dependencies, like where we have context mapping with domain-driven design, to visualize then the change coupling. So if we have a tightly coupled system, then of course you can't adapt to changes quickly, because we have to touch so many pieces of our system to make this change effective. Not only the parts of our system, but also the teams that are responsible for these separate parts. So it's not only about the technical aspect of tight change coupling due to model propagation, where you change the data structure of one component or one bounded context or one domain model within one model context and affects other bounded contexts, but also through the teams owning this bounded context needs to coordinate and communicate in an ongoing manner in order to make this change effective. But it's also related to the team communication, the team coordination. So we have to focus on cross-functional autonomous teams that are responsible for the system, or the part of the system they are responsible for. They don't have to constantly coordinate and communicate with other teams. And also like having other teams helping them, the extreme aligned teams in the team topology sense, that they can focus on a steady flow of feature deliveries, for example. So bringing in the perspective also, the reason why we should also then break it into smaller parts is that we should not exceed the team's cognitive load, because when exceeding the team cognitive load, we are then running into delivery bottlenecks again, and with quality issues, and also decreasing the team's motivation as well.
So thanks for sharing how all these three techniques can actually help you to be more adaptive and also support change. So change doesn't become the constraint for all the teams and parts involved, but at the same time, also change just flows through the system, and we can also isolate the change not to be impacting so many areas.